Okay, hello, BC Part 1. It is me, and let me clear my voice and say, Daniel, with your permission, dear sir, may I proceed with this screencast? And hopefully you are all laughing as I was laughing at myself as well. Though intending or assuming benevolent intent, Daniel, I don't think in any way you were suggesting that you could give me permission to proceed with the business at hand. But if you actually were intending that, then perhaps further conversation is required. Okay, in this screencast, I am going to be deriving for you a formula for a sum of a geometric or a arithmetic series, okay? So first of all, let me put up here an arithmetic series. And let's say I have the summation from n equals 1 to 7. And yes, look how I changed the index of summation. And if I have this, okay, before I move on to those derivations, I want to ask you to please write this. Actually, you know what? Let's change the upper limit, not make it 7. I just don't feel like drawing out so many things. Let's just make it 4. Okay? Write this sum, please, in expanded form. This is why it's so very important to know what the index is, because here, if I were to write the first term, it would be a times 1 plus 7. That's the first term, okay? Plus a times 2 plus 7, plus a times 3 plus 7, plus a times 4 plus 7, all right? And then here you would simplify and make this 4a, 7a, 10a plus 28 is your final sum. So I don't remember who it was that asked in class today, does it matter what the index is? Yes, it absolutely does matter. And you absolutely do have to make sure that you are inputting in the integral changes in the index only in that which is the index within the summand, okay? Most often the index is often k, but it could be any letter. It could be j or I or p or q, all right? Okay, so now let's get on to the derivation. Well, sometimes a couple of things I want to show you is you may see things like this. You may see the series be described by, oh, no, that's not what I want to do. Okay, let a series be described by the following. Okay, I'll do this. 3 plus 5 plus 7 plus 9 plus 11 plus ... Okay? You may find this notation. I actually have no idea if your textbook, Algebra 2 textbook, uses this, but I'm going to show it to you anyway. You may find something like this. Find S sub 3. Okay, what does this notation mean? It's a capital S subscript 3. This notation means the third, it's called the third partial sum. Okay, and what a third partial sum of an infinite series is the sum of the first 3 terms. Okay, so when you have an infinite series, there are various sums you can compute. The third partial sum is just the sum of the first 3 terms, which in this case would equal 15. So S sub 3 equals 15. Now you have to be careful. S sub 3 is 15, but if I asked you what the third term of the series is, the third term of the series is 7. So again, being very careful with semantics, okay? Similarly, if I did this, S sub 5, okay? The fifth partial sum would be the sum of 3 plus 5 plus 7 plus 9 plus 11, and I think that's going to equal what? Does that equal 10? What is it? 11 plus 9 is 20, 35. Okay, that's the fifth partial sum. Okay, well, let's see. Let's see if I can find an expression for the nth partial sum. Okay, and when I ask the question S sub n, really what I'm asking for essentially is there a closed formula, right? Is there a formula for the sum of the first n terms of what kind of a series? Of an arithmetic series. I think I may have just said geometric when I was speaking just now. Sorry for the speako. Okay, is there a formula for the sum of the first n terms of an arithmetic series? Okay, and this is where I think, Arusha, you were kind of telling people in class. You may have seen this. This is a very, this derivation is a very popular like math competition question, asking kids to figure this out, but I'll show it to you anyway. In other words, if I said find the sum of the first 70 terms, right, the 70th partial sum, is there a shortcut that doesn't require me to write out 70 terms and add them up? The answer is yes, and I am going to derive it for you right here. Oh, but you know what? Before we move on, I want to make sure we do one thing. So I'm actually going to go down here a second because I knew. Hi, Tyler. I need about 10 minutes, okay?
10 minutes?
Yes. Okay, one thing I want to make sure that we do here is that when you read this, okay, I want to make sure you know how to say it correctly. So when you say this, this is how you read this. You say this, you say the following: the summation, I didn't write this in class, from n equals 1 to n equals 4 of the quantity an plus 7. Okay, that's how you say this. Very important. The summation from, what follows after the from are the lower and upper limits of summation. Okay, what follows the of, it's the summand. All right, so that's how you say that. Okay, one little detail I wanted to make sure that you knew. All right, so the question is, what is the formula for the nth partial sum of an arithmetic series? Well, I'm going to derive it for you right here, and these derivations I should tell you right now, they are not anything that I myself just kind of create on my own. Some of them are, but this one is not. This one is one that you likely have all seen before, I'm sure. But, all right, here we go. Let me derive it for you. Uh-oh. Oh, no, I think I have a... Okay. Are you ready? Here it goes. Oops, hang on one second. All right, so here's what we're going to do. You ready? Well, we know that the summation of n terms of an arithmetic series is equal to, okay, a sub 1, right, the first term of the sequence, plus the second term of the sequence is a sub 1 plus 1d, right? Plus the third term of this sequence is a sub 1 plus 2d, and I'm saying the third term of the sequence that we are adding after all because it's a series, plus the first term plus 3 of the constant differences, okay? And I'll say this, boys and girls, when I do a derivation, there is no need for you to copy it down unless you really want to. There's no need. All right, a sub 1 plus da-da-da-da. Okay, plus all the way through. Let me go over here. Hang on a minute. Okay, 1 minute.
You all packed up, Bubba?
Okay, plus. Wait a minute, hold on. Plus, okay. Oh, here I am. A sub 1 plus 4 of the constant differences plus da 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 Okay, let's go to the very last term, which would be, okay, careful, right? If we're looking at the summation of n terms, the last term is going to be the nth term. So while I've called this a sub 1, and then a sub 1 plus d, a sub 1 plus 2d, a sub 1 plus 3d, my very last term is going to be a sub 1 plus how many d's? How many d's? Yes, n minus 1 d's. I'll put a bracket here. This is the nth term, after all. This is the nth term. Okay? Or I could say this is equal to a sub n, right? It's the nth term. Okay, very good. Well, let's see. I want you to work backwards now. So see how if we head this way, right? It goes, watch my little arrow. It goes a sub 1 plus 0d plus 1d plus 2d plus 3d plus 4d. If I head this way, boys and girls, it goes 4d plus 3d plus 2d. In other words, the number of d's you add decrease in this direction, but increase in this direction. That means this is the a sub nth term. What's the term right before it? It is a sub 1 plus how many d's? Yes, plus how many d's? Did you hear what I said? Yes, plus n minus 2 d's. Hold on a second. Oh. Okay, now let me pause and resume my camera. Hang on a minute. Okay, is this too small? Yes, I think this is too small. Cameron, what's happening? Why do I think Cameron would know what's happening? I don't know why. All right, how is that? Is this better? So for some reason it's, all right, I think you can read this, right? Okay, the answer is yes. Very good. All right, well, now I'm going to do some playing around with things. Remember, this is the sum of the first n terms of an arithmetic series. Do you see this? Yes, you do. Very good. This is the first term. This is the nth term. And all I did was I found the nth term here, and this is the n minus first term, correct? Very good. All right, now I'm going to do this. I'm going to do some playing, okay? All I'm going to do is flesh this out. This is the same thing as a sub 1 plus dn minus d, correct? And let's not forget, this is another way of saying a sub n. This is the very last term of the series. Okay, I'm going to flesh this out, which is the n minus first term. Okay, a sub 1 plus nd minus 2d. Oh, interesting. So really, if you look at this, this is the n minus first term. This is the nth term, or the last term. Do you see that this second to last term is the same thing as, look what I'm going to do here. Watch me, watch me, watch me. If I took this expression, which equals a sub n, and if I did this, a sub n minus d, look what I'm going to do. Subtract d from the right-hand side, subtract d from the left-hand side, I get this, right? I subtracted d here, subtracted d here. Everyone okay? So, whoa, that's very cool because this is this expression. So I'm going to rewrite this now. I'm going to, instead of calling the n minus first term this, and the nth term this, I'm going to rewrite this whole nth partial sum as s sub n equals, all right, here we go, a sub 1 plus a sub 1 plus 1d plus a sub 1 plus 2d plus a sub 1 plus 3d. I think I'm not going to write this one. Are you okay with that? Okay, good. Daniel, are you okay with this? Okay, good. Plus dot 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 dot. Here is the second to last term. It is a sub n minus d, right? Because this is the n minus first term, but we saw that, whoa, the n minus first term is the same thing as a sub n minus d. And I'm just going to call the last term here, I'm just going to call it by a sub n. Okay? All right, so all I did was just rewrote in expanded form the nth partial sum of an arithmetic series. Arithmetic, by the way. Okay? But I haven't derived anything yet for you. All right, now I'm going to engage in some trickery. All I'm going to do is, below this equation, I'm going to write another valid equation, which is this. The summation of n terms is equal to, I'm going to write this out, but just reverse the terms. So if x plus y plus z plus q equals s sub n, then q plus z plus y plus x equals a sub n, doesn't it? Yes, indeed it does. So are you ready? I'm going to say, okay, this is equal to a sub n plus a sub n minus d, okay, plus a sub n minus 2d, okay, because again, I'm following a pattern here, a sub n minus 1d, a sub n minus 2d would be the next term back here, right? Plus a sub n minus 3d plus dot, 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 dot. Okay, what term would go here? If I'm writing this sum backwards, well, this would be, oh goodness, this would be plus a sub 1 plus d plus a sub 1, right? So the green and the black are identical, just one is forward, one is backwards. All right, now what am I going to do? Well, guess what you can do, boys and girls? When you have two equations, what can you do with two equations? Two equations can be added. Simple example right here. If 3 plus 7 equals 10 and 4 minus 6 equals negative 2, if those are two valid equations, then you are allowed to add those two equations and say 7 plus 1 has to equal 8. See, you can add, add, add. I'm going to do that right now. I'm going to add these two equations. Oh, isn't this interesting? When I add to the left-hand side, I get 2 s sub n's equals, okay, a sub 1 plus a sub n is a sub 1 plus a sub n. That's these two added, right? Now let's add these two. I'm going on a diagonal here. When I add these two terms, what cancels? Yes, the positive d and negative d. I'm going to get plus a sub 1 plus a sub n. When I add these two, what do I get? Yes, I get plus a sub 1 plus a sub n. Same thing here. What do I get here? So let's do plus dot 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 plus plus. Here I get a sub 1 plus a sub n. Finally, I get plus a sub 1 plus a sub n. Let me ask you this. How many a sub 1 plus a sub n's are there? If I have 1 banana plus 1 banana plus 1 banana, how many bananas are there? There are n bananas. There are n a sub 1 plus a sub n's. This equals 2 s sub n. Oh my, and look what we have. We have just derived for you a beautiful formula that gives you the nth partial sum of an arithmetic series. So let's go back to the example above. The example above was asking you for the 70th partial sum of this arithmetic series. Well, what can you do? The 70th partial sum, okay, so the 70th partial sum would require you to find n, well this is 70, times a sub 1, whoops, this should be an n, I'm sorry, it should be n. A sub 1 was, what is it? 3 plus, we need the 70th term all over 2. Okay, then question to you is how to find a sub 70? Well, that is an old question from the days of sequences, which was yesterday. Well, for an arithmetic sequence, we know, and they'll come going back and forth here, we know that for an arithmetic sequence, a sub n equals 3 plus 2 times n minus 1, because the constant difference here was 2, is that right? Yes, okay. So then I have to find the 70th term. A sub 70 will equal 3 plus 2 times 69, which equals 3 plus 2. What is 69 times 2? 138? Yeah, 138, which equals 141. So then that is the 70th term of the sequence. So going back to the work where I left off with right here. Boop, boop, boop. The summation. Oh, I did not mean to do that. The 70th partial sum will equal 70 times 3 plus 141, all divided by 2. Please then use your brain or a calculator device, just do the plug and chug. This is going to be some number, a number in there, okay? Be careful when you use a formula, any formula. Number one, we have just derived where an arithmetic series' partial sum just came from. I think you would agree using this is much easier than writing out 70 terms and then adding them up, right? Very good. All right, so what I'm going to do right now is give you the homework that accompanies this screencast, and then you are going to, with me, when I see you next, we're going to derive the formula for a partial sum of a geometric series, okay? Let me go find your text and put this homework up. I will say this homework here for this screencast we'll go over, well, tomorrow is our question day, right? So we likely won't go over it until Thursday, okay? Let me go find your homework now. Okay, here it is. And with that, I will say good night.